Welcome back, guys. So in previous lecture we have seen a simplified resistive circuit. So today we are going to solve a very simple RL circuit. So suppose we have a resistor and the inductor here, okay, and the applied voltage here is again 10 volts, which is V naught of t, okay, and also again we are going to find out the value of I of t. Okay, so this is now, let me have it 1 ohm, okay, for the simplicity this is 1 ohm, and this is also, this L is also 1 Henry here, while this is resistor. Okay, so now in order to convert it into the S domain, and in converting it to the S domain and then looking at this like here, where this will be the input here and here we will get the output, and here at this block we will have to use the transfer function. Okay, so converting it into the S domain, so here this resistor will remain same 1 ohm, while the inductor here will be transformed into what? That would be transformed into SL, where L is 1, so it will be equal to the S multiplied by 1, so here it will be 1. Okay, and here the input voltage is how much? That is V naught of S, and that is 10 divided by S. Okay, similarly the current inside of it is also I of S, which I want to find out. Okay, so the equivalent resistance it will have will be how much? We can see that it will be here. So here these two are in series, so in series these will be S plus 1, while the input is now 10 by S, while this is I of S. So now in order to find out the required quantities, what we have to do? We have to find the transfer function here, and here the transfer function is Vs equal to the S plus 1 multiplied by I of S, or the output is I of S. So here the I of S divided by V of S is how much? That is 1 over S plus 1, and that is called the transfer function of my system. Okay, so writing the transfer function here, what I will get here, it will be S plus 1. Okay, and the input here is what? That is a DC 10 signal, so that would be 10 by S. So now the output here, if that is V naught of S, and the output here is I of S, so these two will be multiplied together, and at the end the I of S will be 10 by S multiplied by 1 over S plus 1, or it would be 10 divided by S into S plus 1. So that is the value of current in what? In S domain. So now in order to find the value of the current in time domain, what we have to do? We have to convert it back into the time domain. So in order to do it, we are going to use another method here. So in order to do it, let me represent it with, this is I of S, so I of S is S plus 1. Okay, so in order to represent it as a partial fraction, what we have to do? We have to write each of these multiplied term as a separate fraction and adding them. So A by S plus B by S plus 1, where A and B are the unknown coefficients. Okay, so now in order to find the values of A and B, what we have to do? We have to multiply both sides of my equation by S into S plus 1. So by multiplying it, what I will get? I will get here 10, because this S plus 1 will be cancelled out, and here I will get S plus 1. Okay, similarly B S. Okay, so now in order to find the different values here, let me first put S equal to 0. Okay, so when S will be equal to 0, this will become 10, it will be s plus 1 is 1 and it will become 0. So, the value of a will be 10. Okay. Similarly, now putting the value of s equal to minus 1 here in this equation, what I will get? I will get here this 10 here, and what will be here? So, it will be 0 now. Okay. Putting the value of s minus 1 will make it 0, and similarly here it will be minus b, or the value of b will be equal to the minus 10. Okay. Now, taking these values, okay, and let me call it equation A, and putting them in equation A, what I will get? I will get here I of s is how much? That is 10 divided by s and minus 10 divided by s plus 1. Okay. So, now let me find the inverse Laplace transform of it, and taking inverse Laplace transform of both sides of it, I of s equal to the f inverse of 10 by s minus 10 by s plus 1. Okay. Or by the linear property of it, what I can get here, it will be I of s equal to the 10 linear property of s, it will be 1 over s and minus 10 and inverse Laplace transform of s plus 1. Okay. So, we can very easily see here that the values from the table, you can see that the values they have will be here, it will be I of t in time domain, while it will become 10 u of t. Okay. And that would be minus 10, it will be exponential of minus t, minus 1 t. So, it will be this one, or more easily we can also represent it like I of t will be equal to the 10 minus 10 exponential of minus t. So, that is basically the output, and that is in amperes. So, that is the result which we have here, and that is the output. So, let me have a look here as well. Okay. So, that is the question, and here we can also see that this term is what? This is the exponential decaying term. So, here it will decay exponentially, and at one instance it will almost become 0. So, this inductive term will be 0, and that is because of the short term nature of the inductor, which will be for higher value of t. This current I of t will be how much? That would be 10 amperes at the values where time will reach to the infinity. Okay. So, it basically also satisfied or also give me the answer that for the DC terms, the inductor behaves as a short circuit for the steady state condition. So, thank you so much, and today we have also discussed the RL circuit and its solution in the S domain. So, thank you so much, and I will see you soon.